Hello and welcome to Problem Solving in Science using Dimensional Analysis. Utilizing dimensional analysis will actually allow you to solve multi-step problems in one step. We're going to start this a little bit in this unit. One of our later units will utilize this quite extensively. If you go on to college chemistry, this is an unavoidable skill. So this is a very important thing to get a nice base in. And this involves using something called a conversion factor or a conversion fraction. And this is a fraction that is equal to 1. It doesn't look like it's equal to 1 because it will have non-1 numbers in it, but it is actually equal to 1. So writing a conversion factor is fairly straightforward. You have to think about two things that are equal to one another. For example, there are 1,000 meters in a kilometer. Therefore, 1,000 meters equals 1 kilometer, and they can actually be written as what we call a conversion factor or a conversion fraction. So you can say 1,000 meters over 1 kilometer. Those are equal. That's really a fraction equal to 1. You could also write this the other way around and say 1 kilometer is equal to 1,000 meters. What's very important to understand here as we get into math with these conversion factors, especially with metrics, these are considered to be exact numbers. Therefore, they have unlimited sig figs. There are going to be times when maybe this isn't so much true, but most of the stuff that we do, that will be equal, or that will be true. So we want to talk about centimeters and meters. So there's 100 centimeters in 1 meter. Therefore, you could say 100 centimeters is equal to 1 meter, or 1 meter is equal to 100 centimeters. Now I know you're kind of like, what's the point of this? But when we're doing conversions and solving problems, that's going to come into play. So here's an example of a question or a conversion problem that we could do. So we're going to say, what we're actually allowed to do here is we're allowed to multiply anything by 1 anytime we want to in math. So our conversion factors are actually equal to 1. This is also known as the factor label method sometimes because this allows us to actually eliminate or cancel units. So we're going to convert the 15-kilometer mountain goat run that runs through Syracuse into miles. The conversion factor that we're going to use is right here. In fact, there are 1.61 kilometers in a mile. So step 1, sometimes I like to first think about my possible conversion factors. Sometimes you can do that as your step 2. As you get comfortable with these, you can determine that for yourself. So we have 2 possible conversion factors that we could use. 1.61 kilometers over 1 mile, or 1 mile over 1.61 kilometers. So my starting amount is what's given to me in the problem. That's 15 kilometers. And my conversion factor, what I want to be able to do is I want to be able to cancel this. Now, as you hopefully remember from math, in order to cancel something, we have to have it on the bottom. So if there's something on the top, we need something on the bottom to get rid of it. So this tells me that I'm going to want to use this factor since kilometers are on the bottom there. So I'll say 1 mile is equal to 1.61 kilometers. Then I can go ahead and cross out my kilometers. And I'm going to think about what I want my answer to come out in. I want my answer to come out in miles. And my answer is coming out in miles here. So mathematically what I'm actually doing is I'm going to multiply through, or in other words, I multiply everything on the top and everything on the bottom, and then I divide that. Another way that people often write these problems, especially in a college setting, you'd start with the 15 kilometers, and then you'd put this into parentheses and actually make it look like a fraction in parentheses. This means the exact same thing. I don't care which way you do it. I started using the line because I think it's a little bit more quick. So then you're going to go ahead and you're going to multiply 15 times 1 is 15 divided by 1.61. And we're going to come out with 9.3 miles. Now, for a problem like this, you're like, hey, I could have figured that out 10 minutes ago another way. I get it. But, because there are going to be certain problems where this is going to be very beneficial to us. We can also use this for regular straight-up conversions. So if we want to convert between centimeters and kilometers, we could say, okay, here's some stuff I already know. I know how many centimeters are in a meter. I also know how many meters are in a kilometer, okay? So I can write 100 centimeters to 1 meter, 1,000 meters to 1 kilometer. I can write those conversion factors. I can flip them as I need to. So I'm going to start with my starting amount, which is 245 centimeters. First thing that I want to do is I want to cancel centimeters. So I'm like, okay, I see centimeters right here, but that's on top. So what I'm going to do is I'm going to write my 100 centimeters on the bottom and my 1 meter on top. Now it's helpful here, you don't really have to worry about how many centimeters are in a kilometer directly. They actually do a two-step approach to get there. So we're going to get rid of our centimeters. Now I need to have meters on the bottom in my next factor. So I'm going to put 1,000 meters here, 1 kilometer on top. And now I can go ahead and just simply do my math, which is 245 times 1 times 1. So over 100 times 1,000. So it's going to give me a much smaller number. So this gives me 0.00245 kilometers, or 2.45 times 10 to the negative 3 kilometers. Again, the other way to write this would be parentheses. I don't care if you do this, but I will show it to you so you can see it. So you would write 245 centimeters, 1 meter over 100 centimeters, 1 kilometer over 1,000 meters. This can also be used for actual problem solving. And that's more the kind of stuff we're going to get into. I haven't really shown you any of those types of problems yet, but here's an applicable problem that we can use with conversion factors. So let's say that your car has a fuel efficiency of 22 miles per gallon, and you wanted to drive to Albany, which is 159 miles away. How much would you spend on gas if gas is $3.75 a gallon? So let's keep in mind what some of these actually look like as conversion factors. We have 22 miles, 1 gallon. Could also be written 1 gallon, 22 miles. 159 miles away, has to stay as it is. It's not a conversion factor. We also have $3.75 over 1 gallon. I should probably be a little bit more consistent and abbreviate that the same way. Gallon. Or you could also say 1 gallon is equal to $3.75. So my starting amount is going to be my thing that isn't, related to another quantity. So I'm going to start with 159 miles. Now I need to get rid of miles. So I need miles on the bottom. So then I say to myself, okay, I got miles on the bottom and this conversion factor. So I'm going to go 1 gallon over 22.0 miles. And then that will allow me to cancel out my miles. Now I have to get rid of gallons. So I'm going to need gallons on the bottom. So I look at my two factors that I made over here. This one right here gives me gallons on the bottom. So I'm going to have 1 gallon. And I'm going to have $3.75 on top. Now at this point, I can go ahead and simply do my math. Remember, mathematically what I'm doing here is 159 times 1 times 3.75 divided by 22 times 1, 22. So you're going to punch all that in. You're going to find out that this trip is going to cost $27.1 or $27.10. So we're going to do one more problem together before I end the video. We have 9 class periods here at Marcellus High School. If you zone out for 5 minutes every class period, how many hours of education will you have missed in a 180-day school year? So what's kind of interesting about this problem is we actually have quite a few conversion factors here. So some of the things that we can say, and I'm actually going to open this up on a different screen for a minute to look at some possible conversion factors that we can work with. So some of the things that we know to be true here in Marcellus is that we have 9 periods per day. This particular person, maybe you, maybe a friend, is zoning out for 5 minutes per every 1 period. And the school year has 180 days. I'll call that an S year so it doesn't look weird. Now, there might be other important pieces of information that we need to know in a problem. So as we tackle this, we're going to see what happens. So what we know about this particular person, our starting piece of information about them actually is a top and a bottom here. We know that this person is taking 5 minutes out of every period to zone out. Now, we want to make sure what's actually interesting or useful on this, just look at what we want our answer to end up in. We want to end up finding out how many hours this person misses in a year. So my goal here is going to be to find out hours per school year this person is missing of education. So I'm going to say, okay, I got to get rid of both minutes and periods. Now, minutes, I do need to get rid of, and I actually need to turn it into something else. I need to turn minutes into hours. So what do we already know about minutes? We happen to know, and it's not given in the problem, but we know there are 60 minutes in 1 hour. So my minutes are gone. Now I've got hours, which I want in my answer, so that's awesome. Now for periods, I have to look at my conversion factor that had periods in it, so I'm going to use this first one right here. Here in Marcellus, we have periods on the bottom. We need 9 periods on top in 1 school day. Periods have now gone away. And the last thing we need to do is we want this to end up with school years on the bottom. We need to get rid of days. So we say, okay, here in Marcellus, we have 180 days per school year. So we're going to say, oops, 180 days is 1 school year. We're going to go ahead and we're going to cancel our days. Now we ended up with the units we want, which are hours per school year. So you're going to go ahead and do your math. Remember, we got a little bit more going on here. So what's happening is we're going to do 5 times 1 times 9 times 180 divided by 1 times 60 times 1 times 1. So you're going to go ahead and punch that in. To find out, this is 135 wasted hours of education. So I think it's pretty clear. It's important not to zone out during class every day, even for just 5 minutes.